Hey guys, in this video we're going to talk about how to simplify radical expressions. Before we begin simplifying, let's talk about what a radical expression is. A radical expression is any expression that contains a radical sign, such as a square root. So for example, the square root of 5 would be considered a radical expression because it contains a radical sign. Now the radicand is the part that is underneath the radical sign. It could be a variable, it could be a number, it could be the product of those two things. In this particular case, 5 is our radicand because that is the part that is underneath our radical sign. Awesome. Now that we know what a radical expression is and what a radicand is, let's begin the process of simplifying. Looking at this first example, we see the square root of 20. Our first step is going to be to prime factor the radicand. So in this case, I'm going to prime factor 20. 20 breaks up into 2 and 10. 2 is prime, but 10 is not, so 10 breaks up into 2 and 5. Both of those are prime, and so my prime factors here are going to be 2 times 2 times 5. So I rewrite it as the product of its prime factors. Next, we're going to look for perfect squares. Remember that our perfect squares are any numbers that can be, when we take their square root, give us a whole number. So I've listed our perfect squares, our first 10 perfect squares anyways, off to the side for quick reference for us. So do we have any perfect squares underneath this radical sign? Well, no. But what we can do is if I multiply 2 and 2 together, that would give me a perfect square of 4. And so I'm going to do that. So instead of 2 times 2, I'm going to rewrite this as 4 times 5, so square root of 4 times 5. And then my next step would be to take the square root of that perfect square and remove it from underneath the radical sign. So I take the square root of 4, which in this case is 2. 2 gets pulled out from underneath the radical sign, because we took the square root of it. And what we're left with is the part that's on the inside. So we didn't take the square root of 5, so 5 would still be on the inside of our radical. So our simplified radical expression here would be 2 square roots of 5. Awesome. Let's look at another example. So if I'm looking at the square root of 32, again, my first step is going to be to break it up into its prime factors, or attempt to anyways. So in this case, I know that it initially breaks up into 2 and 16. And I'm actually going to stop here because I know that 16 is a perfect square. So this is going to save me some time in the long run. So instead of finding all of its prime factors, I'm just going to stop with 2 and 16. And I'm going to rewrite it as the product of 2 and 16. Now remember, our next step here is to take the square root of that perfect square and remove it out from underneath the radical sign. So if I take the square root of 16, that gives me 4. So 4 comes out from underneath the radical sign, and what we're left with on the inside is 2. And so 2 stays underneath, and so our simplified radical expression here would be 4 square roots of 2. Alright, let's look at some examples with some variables in the mix. We're still going to do the same thing with our coefficient of 54. We're still going to break it up into its prime factors. So if I break up 54 into its prime factors, 54 breaks up into 6 and 9. 9 is actually a perfect square, so I'm going to leave that alone. 6 is not, so I'm still going to continue to break that up into its prime factors of 2 and 3. And so I'm going to initially start off by writing 2 times 3 times 9. Now, what do we do with these variables? We want to make sure that the variables have an exponent that is even, because that's going to help me, that's going to be the way that we're going to be able to take the square root of that. So because a squared and b squared both have even exponents, I'm just going to drop them down in here. So those are going to be considered perfect squares. Alright, our next step here is to take the square root of all of our perfect squares. So in this case, I've got 3 perfect squares. I've got 9. I've got a squared and b squared. Again, I know that a squared and b squared are perfect squares because their exponents are even. So now we're going to take the square root of these. If I take the square root of 9, that becomes 3. And I'm pulling them out from underneath the radical sign, so remember that part. To take the square root of any variable, you're just dividing that exponent in half. So if I divided 2, that would give me 1, so I would have a to the first power, or just a. The square root of b squared would be b, or b to the first power. So same thing that we did for that a. And then what I'm left with on the inside is 2 times 3. I'm going to combine those to give me 6. And so my simplified radical expression here would be 3ab times the square root of 6. Alright, let's look at another example. So again, with 40, w to the 4th, y to the 5th, and z cubed, if I want to take the square root of that, I'm going to initially start by taking 40 and breaking it up into its prime factors. So now that 40 breaks up into 4 and 10, 4 is a perfect square. 10 breaks up into 2 and 5, and so I'm going to start off by rewriting it so that it's 2 times 4 times 5. Now remember, we want the variables to have an even exponent. So w to the 4th, we're good with. Y to the fifth we're not. So here's how I'm going to fix this. I'm going to rewrite y to the fifth as two factors. I'm going to drop the exponent down by 1. So I'm going to make it y to the fourth. And then I'm going to multiply it times y. I know that if I or y to the first. So I know that if I multiply y to the fourth and y to the first, based off of our laws of exponents, that when I multiply them, I would add those exponents together, and that would give me y to the fifth. So I'm just rewriting it so that I have an even exponent there. We're going to do the same thing with z cubed. So z cubed gets broken up into z squared times z. Drop the exponent by 1 and then multiply by the variable. Now we're going to take the square root of each of our perfect squares. So in this case, that would be 4, w to the fourth, y to the fourth, and z squared. The square root of 4 is 2. The square root of w to the fourth is w squared. Remember, divide the exponent by 2. Y to the fourth would be y squared. Z squared would be z. And then what we're left with on the inside is 2 times 5, which is 10. Y to the first power, or just y, and z. And so my simplified radical expression here is 2w squared, y squared, z, and then the square root of 10yz. Now what do we do when there's already something outside of the radical sign? What we're going to do is whenever we're taking out those perfect squares, we're actually going to multiply them to whatever is on the outside. So let's start off with our process. We have 45. I'm going to prime factor it. I know it breaks up into 3 and 15. Neither of those are, or 15 is not prime. So 15 breaks up into 3 and 5. And so I'm going to rewrite this. This is negative 3y. And then 3 times 3 times 5. Now I notice here that 3 times 3, if I multiply that, will give me a perfect square of 9. So I'm just going to rewrite that now as 9 times 5. It'll save me some time. And then y cubed, we're going to change the exponent so that we have one that is even. So y cubed breaks up into y squared times y. Z cubed breaks up into z squared times z. And then we're going to begin taking the square root of each of our perfect squares. So taking the square root of 9, of 2, and of y squared and z squared. So the square root of 9 is 3. Now remember, when I'm taking that out, I need to multiply it to whatever's there. So 3 times negative 3 will give me negative 9. The square root of y squared is y. Again, I'm going to multiply this to the y that's already out there, so it's going to give me y squared. Z squared is z. There is nothing to multiply the z to, so I'm just going to bring out the z. And then what we're left with on the inside is 5yz. Guys, this is how you simplify radical expressions. And if you have questions, feel free to reach out to us, and we will be more than willing to help you.